In 2006, scientists detected something alarming. Methane levels in our atmosphere suddenly spiked, and they're still rising today.
Methane is a natural gas that traps heat. Like a blanket, it wraps around Earth, keeping warmth trapped inside.
Methane traps heat far more effectively than carbon dioxide. It's one of the most potent greenhouse gases known.
Scientists initially blamed human pollution, but the truth revealed something far more mysterious hidden within our planet. How is this gas produced? Why is it rising now? And most importantly, what does it mean?
Scientists knew methane spikes occur every 100,000 years. Ice cores from Antarctica reveal this ancient pattern.
In Antarctica, researchers drilled deep into ancient ice. Each meter represents 1 year of atmospheric history trapped forever.
Snow falls annually, trapping air bubbles. Drilling deep acts like traveling back in time, revealing atmospheric secrets.
By analyzing trapped air, scientists determined which gases existed in each century. Patterns emerged from millennia of data.
History revealed a shocking pattern. Every 100,000 years, methane spikes dramatically. Each spike marks the end of an ice age. When this happens, Earth warms rapidly within decades.
When ice ages end, warming happens incredibly fast. Within just 20 to 30 years, massive ice disappears.
But there's a problem. The last spike occurred 12,000 years ago. Why is it happening again so soon?
To understand why, we must examine Earth's recent history. We're in the Quaternary period.
The Pleistocene epoch saw repeated ice ages. This era witnessed early
12,000 years ago, the Holocene began. Climate stabilized, allowing humans to develop agriculture and build civilizations.
We're in a warm period now. But technically, we're still in an ice age, because ice remains at both poles.
A true ice age end means no polar ice whatsoever. That hasn't happened yet. But could it?
What natural force warms Earth enough to end ice ages? Scientists identified 3 critical cycles controlling our climate.
Named after scientist Milutin Milankovitch, these 3 astronomical cycles dictate Earth's long-term climate. Here's how they work.
First, eccentricity. Earth's orbit shifts from circular to elliptical over 100,000 years. This changes solar heat received.
At certain orbital positions, Earth receives significantly more solar energy. This additional heat can trigger dramatic climate shifts.
Second, axial tilt. Earth currently tilts at 23.5 degrees, but this angle isn't constant. It changes.
Every 41,000 years, Earth's tilt shifts between 22 and 24.5 degrees, changing polar sunlight dramatically.
Third, precession. Earth's axis wobbles like a spinning top every 19 to 23,000 years, altering seasonal timing. These 3 cycles work together. When they align perfectly, they trigger powerful warming, melting ice, and ending ice ages.
When these cycles trigger warming, ice begins melting. As bright white ice disappears, something critical happens beneath.
White ice reflects sunlight back to space. Dark ground absorbs it. This difference creates a powerful feedback loop.
More dark surface means more heat absorption. More heat means faster melting. The process accelerates exponentially.
Beneath frozen ground lies permafrost, soil that's been frozen for thousands of years, trapping ancient organic matter inside.
As warming continues, permafrost thaws. Ancient organic matter decomposes, releasing massive...
But why the 2006 spike? The last ice age cycle reset only 12,000 years ago. What's causing this?
In the 1900s, industrial emissions increased dramatically. Natural gas industries exploded.
But by 1990, these emissions stabilized. The 2006 spike came from somewhere else entirely.
Methane is produced naturally in wetlands and oceans. Microscopic organisms generate it during decomposition.
Scientists use satellites with laser beams to detect methane. If the beam doesn't reflect back, methane absorbed it. This laser technology identifies methane concentrations precisely. Scientists can map exact locations of emissions from space.
NASA created comprehensive methane maps. They discovered super-emitters, locations releasing staggering amounts of gas constantly.
A massive Iranian landfill releases 73,000 tons annually. That equals emissions from 180 Boeing jumbo jets.
Turkmenistan has 12 points leaking 40,000 kilograms of methane every single hour from oil and gas operations.
But here's the shocking truth. Half of the spike comes from forests, specifically those sitting over melting permafrost.
Beneath these forests, ancient organic matter trapped for millennia is finally decomposing, releasing methane that's been frozen forever. Atmospheric methane is nearly impossible to collect. Once released into air, it disperses and becomes incredibly difficult to capture.
Landfills can capture methane and convert it to energy. This produces carbon dioxide, which is less harmful than methane.
But forest emissions are completely uncontrollable. The scale is too vast, the sources too dispersed to manage.
Methane lasts about 10 years in the atmosphere before naturally breaking down into carbon dioxide and water vapor. Through atmospheric reactions, methane eventually transforms. But during those 10 years, it traps enormous amounts of heat.
We've never witnessed such high methane levels so soon after an ice age. This is completely unprecedented in recorded history.
Both polar ice caps remain today, but they're retreating. Satellite measurements show continuous decline year after year.
The Arctic is warming twice as fast as the rest of Earth. This amplified warming accelerates global climate change. Greenland's ice sheet holds enough water to raise global sea levels significantly. Its melting rate is accelerating dramatically.
Antarctica holds 90% of Earth's ice. Its stability determines our planet's future. Scientists monitor it constantly.
Warm ocean currents melt ice from below, invisible from surface. This hidden process destabilizes massive ice shelves. The feedback loop is self-reinforcing. Each step amplifies the next, creating exponential acceleration difficult to stop. Scientists warn of tipping points, critical thresholds beyond which changes become irreversible and self-sustaining. Are we approaching them?
Global temperatures are rising faster than predicted. Each decade breaks previous records. The trend is unmistakable and accelerating.
Oceans absorb over 90% of excess heat. This thermal storage delays atmospheric warming but raises ocean temperatures.
Warming oceans stress marine ecosystems. Coral reefs bleach and die. Fish populations decline. Entire food chains collapse.
Climate change intensifies extreme weather. Hurricanes strengthen, droughts lengthen, wildfire.
Agriculture faces unprecedented challenges. Unpredictable weather disrupts growing seasons. Food security becomes uncertain for millions worldwide.
Rising seas and extreme weather force millions to relocate. Climate migration is beginning, creating... Scientists deploy comprehensive monitoring systems worldwide. Satellites, sensors, and stations track...
Supercomputers run complex climate models, simulating future scenarios. These projections guide policy decisions and scientific understanding. The future isn't predetermined. Multiple scenarios exist depending on actions taken now. Each choice leads to different outcomes. Scientists agree rapid emission reductions are essential. Current trajectories exceed safe warming limits. Action must be immediate. Renewable energy is expanding rapidly. Solar and wind power grow exponentially. Technology advances make clean energy increasingly affordable. Carbon capture technology is developing. Machines remove carbon dioxide directly from air. But scaling remains challenging and expensive.
Natural solutions help too. Reforestation absorbs carbon. Wetland restoration reduces emissions.
Climate change demands global cooperation. No nation can solve this alone. International agreements coordinate worldwide action. Innovation accelerates daily. New technologies emerge constantly. Human ingenuity provides hope. Solutions exist if deployed rapidly enough. Individual actions matter. Millions of small choices create massive change. Each person's contribution combines into collective transformation.
We stand at a crossroads. One path leads to catastrophe. The other.
Time is short, but hope remains. Young generations demand action. Technology advances. Political will grows. Change is possible.
This is our planet, our only home. The Methane Mystery Revealed.